Hello everyone! Today, we're diving into a fascinating topic in materials science. We'll explore how a powerful technique called Differential Scanning Calorimetry, or DSC, is used to measure a crucial property of polymers, the glass transition temperature, often called TG. It might sound complicated, but we're going to break it down in a very simple way. First, what is the glass transition? Imagine a hard, brittle piece of plastic. If you warm it up, it doesn't melt right away. Instead, it first becomes soft, flexible, and rubbery. This change from a rigid, glassy state to a more pliable, rubbery state happens at the glass transition temperature. It's a fundamental property that tells us a lot about how a material will behave. Now, how do we find this exact temperature? That's where DSC comes in. The name itself gives us clues. Differential scanning calorimetry means we measure a difference in heat flow while scanning across a range of temperatures. Here's how it works. Inside the DSC machine, there are two tiny pans sitting on heaters. We place a small amount of our sample material, like that piece of plastic, into one pan. The other pan is left empty to act as a reference. The machine then begins to heat both pans at a precise and constant rate, for example, 10 degrees Celsius per minute. The core job of the DSC is to measure exactly how much energy, or heat, it takes to keep the sample pan at the very same temperature as the empty reference pan. As the temperature rises, something special happens when the sample reaches its TG. Below the TG, the long polymer chains in the plastic are essentially frozen in place. It takes a predictable amount of energy to heat them up. But right at the TG, these chains gain enough energy to start wiggling, rotating, and sliding past one another. This new freedom of movement allows the material to absorb more heat energy. Because it can now soak up more heat, the DSC machine has to supply more power to the sample pan to keep it heating at the same rate as the reference pan. This change is what the DSC detects. On the output graph, which plots heat flow versus temperature, you don't see a sharp peak like you would for melting. Instead, you see a distinct step or a shift in the baseline. The line literally steps up to a new level. This step change signifies an increase in the material's heat capacity, which is the direct result of the polymer chains starting to move. The glass transition temperature, or TG, is typically identified right in the middle of the step. And that's the fundamental way DSC pinpoints this critical transition from a hard solid to a soft one. Thank you so much for watching. If you found this explanation helpful and want to learn more about the fascinating world of materials, please consider liking this video and subscribing to support the channel. It truly helps us create more content for you. We'll see you in the next one.